Good day, grade 11s. Welcome to another series of iCamp lessons. If you are seeing this on YouTube, please don't forget to subscribe, comment, like, share the video. Right, so today we'll be covering intro to graphs of trigonometric functions, right? So to just remind you of what we mean by trigonometric functions. So your trig functions, right? Your trig functions will be your sine, right? Your cosine, and then your tangent, right? Right, which you would ordinarily know as sine theta, right? Your cos theta and your tan theta, right? It does not really have to be theta always. It can be beta, it can be x, it can be y. But yeah, that's how we usually represent them. So there are important concepts that we need to understand when we dive into this topic, right? And I've tried to summarize them into simplest terms here. But these are one of the most important concepts when it comes to this topic. It will help you understand this topic better if you grasp the concepts and understand them. Excuse me. So the first one will be your amplitude, right? So your amplitude, there's various ways of defining it, but the simplest way of defining it is the maximum height of the graph from its origin, right? It's the maximum height of the graph from its origin. So what do we mean by that, right? Take for instance, if we look at this dark green graph here, right? Where is its origin? So this will be your origin of the graph, which is the x-axis. So what we mean when we say the maximum height of the graph from its origin, it should be from the distance from here to here, right? So this will be your amplitude, right? That will be your amplitude. Great. Now if we look at the light gray, the light green graph, right, which goes from here to here, right? It's this one, right? So where is the origin of the graph? This is the origin, right? This is what we will call the origin of the x-axis, which here we refer to it as x prime, right? It's x prime. It's actually the same graph, but it has translated up by x amount of units, right? We'll get into that later on. So this graph has translated up, right? But this is the origin. So the graph starts here, goes. So if we want the amplitude, so we take the origin, right? It will be here, the x-axis, until here. So this will be your amplitude, right? This will be your amplitude, right? So how others usually define it, they say it's the displacement from actually here. So they would say this point, the minimum value plus the maximum value divided by 2. Yeah, but as you can see here, the easiest way is by taking it from here to here, which becomes the maximum height, right? Now if we are moving on to the next one, the period. What do we mean by the period? So I've defined period here as the distance between repetitions of any graph, right? So what do we mean by that, right? So these graphs, they are continuous graphs, right? So they have what we call a period. So a period is how long do we take, the period in physics, how long do we take to complete each cycle, right? So for example, in this case, right, you have a graph that starts here at 0, 0. It goes here, right? and then it comes back, it goes down and then it comes here. So this will define what we call your first period, right? So your period will be the distance, right, from here, right, to here, right? So this is the first repetition. This is the first graph, right? And then it repeats itself, right? Hence we say it's the distance between repetitions of any graph. So between these two repetitions, the distance from here to here will be your period, right? And if we look at it from here again, and then you draw it and then it comes back here, so it means you would have formed two periods now. So this is the first graph, this is its repetition, and this will be your period. The distance from here to here will define what we call your period, right? And then your range, right? A range is a set of values. So it's a difference between the maximum and the minimum value of the graph. So a graph will always have your maximum and your minimum value. So if you take a look at here, right, and if this point was 1, right, and this point was -1, then your range will define it as y, right, because we are looking at the y values, y as an element from -1 until, from +1 until -1, right? Then we have what we call vertical shift. So a vertical shift is the displacement of the graph about the y-axis, right? So we go back, we look at the dark gray, we look at the dark green graph, this one, right? So this is a graph, right? So this is a graph, and it's starting from its origin, from 0, 0 here, right? And if we look at the light gray graph, right, it's literally a replication of the dark green graph. However, the light gray has shifted up, right? It has shifted up by X amount of units. So that's why we call that vertical shift, right? So vertical shift is a displacement of the graph about the y-axis. So it can either go up or go down. It does not always have to go down. It does not always have to go up. It can vertically shift up or down, right? Great. And then you have your phase or your horizontal shift. So your phase or horizontal shift, that's the displacement of the graph about the x-axis, right? This is either the graph will move to the right, right, by X amount of units, or move to the left by X amount of units. If you look at this graph, it has moved to the right by X amount of units, right? So you had the dark green graph, right, but you also have your light gray graph, which has also shifted horizontally to the right, right, and it has also shifted vertically up, right? So those are the important terms that we need to know, and we need to understand these concepts in order to understand this topic, right? Great. So let's move on. Now we are moving to your general forms, right? Your general equations. So for example, here I have y is equals to a sine bx, right? Sine bx, right? And here I also have a cos bx. So if you like, you can just put this into brackets, right? So we'll start with these two, right? So in this case, right, a, right, is what would represent your amplitude. So this a is what would represent your amplitude, right? And the amplitude is represented by the absolute value, right? It's the absolute value, right? So it's gonna be positive. So your absolute value will give you a positive value, right? And then you have what we call a period, right? Period is equals to, because remember these graphs, right? These graphs, right? Your trigonometric graphs, right? The reason why it's 360, right? Your trigonometric graphs, they come from what we call a combination of circle geometry together with your trigonometry, right? So if you remember very well, if you take a unit circle, right? If you take a unit circle, right? Let's just draw a unit circle with radius 1, right? And we draw this on a Cartesian plane, right? So you have your x, you have your y, right? And then this is your radius 1. So you can just say r is equals to 1. And then this will be your point, right? Great. So if I were to construct a line, right, if I were to construct a line here, this was going to form a right triangle, and then this was going to be theta, right? Great. So if I wanted to know the coordinates of P, which is just any point, it's this point, your coordinates of P, which is x, y, right? If I wanted to know these coordinates here, I could use what I call your trigonometric ratios, right? So your trigonometric ratio would say your sine of theta is equals to what? Opposite over hypotenuse. So this would have been y, right? Over, remember this is y, right? This was gonna be y, and then this was gonna be x, right? It was gonna be, yeah. So now you have y over 1 because your hypotenuse is radius of 1, right? So now let's just write this here. So remember, we want the coordinates of P, which is x and y. So we use our trigonometric functions, which is going to be sine of theta is going to be opposite over hypotenuse is going to be y over 1, right? And this would give you just y, right? So now you have y is equals to sine theta, right? So you have y is equals to sine theta, right? And then the same with cos theta is going to be x over 1, right? And then you have x. So it means that your x is going to be cos of theta, right? So that means that the coordinates of P now, they become what? The coordinates of P, they become your cos of theta by sine of theta, right? So because this is a unit circle, right, it means that the maximum that this point, if it was to rotate, right, if it was to rotate, the maximum amount or the maximum number of degrees it can reach is 360, right? It's 360. So this is what we would call, or you would define as your period, because it's from where we start until it's how long or how many degrees we take from the origin back to the origin, right? So if we were to travel here, the point will still be sine theta, cos theta. Obviously the signs would change because of the quadrants, but as we go on, right, the maximum amount of degrees we would reach is 360. So that's what gave rise to the study of your trigonometric graphs, right? It's these concepts, right? Because as they repeat, they form graphs, right? As this point keeps on rotating around this circle, it forms a graph. That's how we have sine graphs. So that's why you have your 360, right? That's how you have your 360. Great. So yeah, that's how we find your 360. So your period is usually, especially for sine and cosine graph, right? Your period is given by this equation. Period is given by, so we can literally erase this. Great. So your period is given by your 360 divided by p. So p is a factor that affects the period, right? So p can be anything. Right, so the reason why we use 2 pi is the same as 360, but it's in radians, right? So this is what we need to know about your your general forms of sine and cosine functions, right? However, we do have also when we talk about your vertical shift, right? So you will have your a sine, right? If we include vertical shifts, right? So now your graph will transform and it will be a sine bx plus q, right? And you still have your y is equals to a cos bx plus q, right? So that's how you represent. So that's how you would represent your. That's how you would represent your vertical shift, right? I hope that's understandable. So that these are the general forms, right? These are the general forms. Great. So now let's look at the example, right, of a graph. This is what we call a sine graph, right? So right here we have y is equal to sine x, right? So the most important thing that you must always remember is that the sine graph will always pass through the origin, right? Always pass to your origin, right? This is your 0 degrees with 0, right? As it can be seen here, it passes through the origin. This is your origin, right? It passes through the origin. So if I were to say, please give me the period of this graph, the period of this graph is going to be 360. Remember, you have y is equals to your sine theta, right? Remember here you will have your invincible 1, right? It's the same thing as having y is equals to your sine 1 theta, right? It's the same thing. So if I were to say give me your period, then your period would be equals to 360 divided by b, and I have 360 degrees equals to 360 degrees over 1. So my period would be 360 degrees. So this would define my period, right? So this is what would define my period. If I were to say give me the amplitude, remember what I said the amplitude is, right? If I were to say give me the amplitude, right? So the amplitude is the maximum height of the graph from the origin. So if I were to take the point here, I will have here to here. So that distance from here to here is going to be 1, as it can be seen here. So amplitude is going to be 1, right? Another way of doing this is I have y is equals to sine theta, and this I can also write it as y is equals to 1 sine 1 of theta, right? Remember what we said. We said the amplitude is the same as the absolute value of 1, which is just 1, which is going to be 1. So in this case, A is 1, so hence we have 1 as our amplitude, right? And then now the last thing that we are going to discuss is the range, right? So the range is the values upon which our graph exists on. So we are going to look at the maximum and the minimum, right? Y value. So it's -1 and 1, right? So you can simply write it as -1 a y, right? This will be our range. This will be our range in this case, right? I hope that's understandable. Great. So here we've covered very important concepts, right? We now know that the graph of sine will always pass through the origin. We know that the period of the sine graph is 360. We also know that the amplitude of the sine graph, in this case, the general sine graph, right, is going to be what? 1, and the range is -1 and 1, right? However, it won't always stay like this, right? So the period can be different, the amplitude can be different, and the range can be different depending on what general formula you are given, right? But this is the basic, right? Great. So now let's look at another one. So let's look at the cosine graph. So we are going to apply the same thing that we did on the sine graph, right? So now we have a cosine graph. You can see that the sine graph passes through what, right? In terms of y, it passes through here. It does not pass through the origin as the cosine graph, right? So it does not pass through what? It does not pass through the origin as the cosine graph. So here it passes through here. It's 0 degrees and 1, right? It's 0 degrees and 1, right? And this makes sense because your cos of 0 should give you 1, right? If you press your cos of 0, it should give you 1, right? So that's how you can think about it. Even when you say y is equals to cos of 0, it should give you 0 degrees, right? It should be 0 degrees. It will always give you 1, right? So that's why it passes through 0 and 1. It passes through these coordinates, right? So now let's look at finding the period, right? Let's start with the easiest one, right? Which is the amplitude. They are all easy, by the way. So the amplitude, remember we are given y is equals to, remember that equation, y is equals to a, right, cos b x, right? So in this case, we are given y is equals to cos x, right? It means that we have 1 here. Y is equals to 1 cos 1x, right? So therefore it means that our amplitude is going to be the absolute value of 1, which is 1, right? Therefore this will be our amplitude, right? That will be our amplitude. Now in terms of the period, right? If we want the period, if now we want the period, it's going to be your period. Remember how your period is given, right? Your period is equal to 360 degrees divided by b, right? In this case, b is equals to 1, right? B is equals to 1. Therefore, your period is going to be 360 divided by 1 equals to 1. No, it should be 360 degrees. So this is what will define your period, right? I want you to take note of this, right? Your period for your sine and your cosine graph, the general sine and cosine graph, right, is always 360, right, as we had already discussed with the unit circle. Right, so now the last one is going to be your range, right? The range is also going to be the same. It's going to be -1, y, and 1, right? So now you have your range. Great. Now we are going to look at the last one, right? Now we are going to look at the last one. So as you can see, you have a very different graph now, which is a graph of tangent, right? So what you need to understand here is that your graph of tangent will not have an amplitude, right? So here your amplitude will be non-applicable, right? It will be non-applicable because we don't have the maximum. This is a continuous graph. It continues from here to here. It will continue until infinite, right? And it will never touch the asymptotes. These are the asymptotes, right? So here we are only talking about asymptotes, not the amplitude. So we only talk about what? The asymptotes. So we only talk about the asymptotes here. Great. And then in terms of the period, right, the period of a tangent graph is 180, right? It's the 180. So as I had defined, if you go back and we define and you understand what the period is, so your period is the distance between repetitions of any graph. So this graph, if we take this as the origin, comes here, so it will come here, from here to here it's going to be 90, and then from here to here it's going to be 90, and this entire distance is going to be 180, right? So your period for a tangent graph is 180, right? So 180. We can also divide this by b, right? That is, if you are given something, y is equals to your a tangent. Remember, we won't have a because the amplitude is non-applicable. So this is tan bx. Right. And then now, what else are we leaving? So in this case, you will have your range, which is going to be just infinity and infinity. Great. So these are the two things that we are going to consider for now, before we move to questions or class example problems. Right, so now let's look at examples on how we draw these graphs and what the impact of these factors, your factors of A, your factors of B, does when it comes to drawing these graphs. Great. So now here we are being asked to graph or to draw the graph of y is equals to sine x over 2, right? So what I'm going to do is I'm just going to try to write this in its easiest form. So I'm just going to say y is going to be equals to 3, right? Sine and then now what I will do, I'll just open a bracket, right? 1 over 2x, right? So now I have written this in the form of y is equals to in this form, y is equals to a sine bx, right? So now it's in that form. So let's just try to write this neatly here. So I've tried to write this in the form of y is equals to a, right, sine bx, right, where a is the amplitude and b affects the period of the graph, right? So the first thing that I'm going to do before I start drawing, I'm going to find the amplitude, right? So my amplitude will be the absolute value of a. So what is the value of a? So this will be the value of a. This will be the value of a, right, which is 3. So it's going to be equals to the absolute value of 3, and the absolute value of 3 is just positive 3. So that means that my amplitude is what? Is 3. Great. Now what I need is my period, right? So now I need a period. Remember, the formula to find the period is going to be 360 degrees divided by b, right? So what is my b? My b is 0.5 or 1 over 2, right? So it's going to be 360 divided by 0.5, because 1 over 2 is the same thing as 0.5, right? So now what's gonna be my period? So when I punch, or you punch your calculator, it means that your period is gonna be 720 degrees, right? So it means that it will take 720 degrees to complete one cycle, right? So that's what it means. That's what this means, right? Now we can go ahead and draw this graph, right? We can go ahead and draw this graph. Remember, it's a graph of sine, right? Remember, it's a graph of sine. It's a graph of sine, so it will pass through the origin, right? Your sine graph, right? It will pass through the origin, right? Pass through the origin. You don't have to cram this. Even if you put sine 0, sine of 0 is always, sine of 0 degrees is always going to give you 0, right? So now let's go ahead and sketch that, right? So I'm gonna have my y-axis here, and this is gonna be my x-axis, right? Remember, it passes through 0. So remember, this is going to end on 720, right? It's going to end on 720, and 720 is the same thing as just 360 times 2. So if this was 360, so let's just say if this is 360, if this is 360 degrees, right, this will be 720 degrees, right? So that's what it means. It means that it will take 720 degrees to complete one cycle. So we can just say this is 360, and then we come here and we just say this is gonna be 720 degrees, right? So if we draw this graph, remember what's the maximum value? The maximum value of the amplitude will be 3, right? So we expect our graph to at least come to here, which is gonna be 3, right? Which is gonna be 3. Yeah. So now we can go ahead and draw the graph, right? So this will be our graph, right? So this will be our graph. So it will start here at the origin, right? It will start here at the origin, and then it will pass 360, and then it will come to here. So it's gonna be a graph looking like this. Right, and then it will come here. So this obviously should be okay. Well, this obviously should be, not sure why I'm not getting a straight line. This should be -3, right? So this is your graph, right? So this is just one graph, right? So this is just one graph. It passes through here. It will pass through 360, and then it will come here. Right? So this is your graph, right? Remember the original graph. Remember the original graph of sine x. So the original graph of sine x, we would have had here 180. Yeah, we would have had 180, and then this was gonna be your 270. It should be 270. Yeah. So if we had our sine x, so let's draw the graph, the original graph of sine x, so that we see what changes were made here, or how the period is affected, right? So if we had our original sine x graph, right, it was gonna be from here, right? This was gonna be, let's just say this is 1. Obviously this is not drawn to scale. This is gonna be -1, -2, right? So if we were to draw the original sine x graph, it was gonna look like this, right? Okay, right? And then goes on here, right? And then it should go here again, right? So this is your original sine x graph. So this is your y is equals to your sine of x graph, right? However, this graph is your y is equals to your 3 sine of 1/2x, right? Can you see the difference here? The difference is this factor, right? This factor affects, it affects the period, right? The period of the graph here, right? It took us 360 degrees to complete one cycle, but now it takes us 720 degrees to complete how many? One cycle, right? So it has reduced it, right? It has reduced it. So that's basically the difference when it comes to these graphs, right? That's basically the difference. So this is how you would ordinarily draw your graph, right? You must always remember to label your axis, right? Why? So down there it's always your degrees, right? And then up there it's gonna be what? Your y-axis, right? So now let's check the cosine graph. Let's check the cosine graph, right? So here we are still just teaching you how to draw these graphs, right? So also here I want to write my equation in the form of y is equals to a cos bx, right? So it's already written. It's y is equals to 1 over 2 cos of 2x, right? So now my amplitude, what will be my amplitude? So my amplitude my amplitude is going to be my absolute value of a. And what is my a? My a is 1 over 2, so which means that my amplitude is just gonna be what? My 1 over 2, or which I can say it's 0.5, right? Great. So this will be my amplitude, right? So now how can I find my period? Remember, what did I say? The maximum number of degrees that cosine can reach in a unit circle is 360. So it will always be 360 divided by this multiplier, right? So your period will be 360 divided by b. What is my b there? It's 360 degrees. What is my b? My b is 2. So it means that 360 degrees divided by 2 is going to be 180. So that means that now it's going to take me 180 degrees to complete one cycle, right? To complete one cycle. And always remember, it's a cosine graph, right? It's a cosine graph, so it will pass through what? If it's a cosine graph, it will pass through what? 0 degrees with 1, right? Because if you put cos of 0 will always be what? Will always be 1, right? So let's go ahead and draw that. So I'll do the same thing here. So I'll just draw my graph. Okay, and then this will be my graph, right? So now remember, it takes me how long now? It takes me 180 to complete one cycle, right? It takes me 180 to complete one cycle. So here I can simply have my 180 degrees, and then I have my 360 degrees, right? So I will have my 180 and I will also have my 360 degrees, right? So let's see how we can draw that. Remember, what will be my amplitude? My amplitude is 0.5, so it means that this graph, right, the maximum it will reach is 0.5. So I can have here my 0.5, and then I can have my 1 here, and then here also I can have my negative 0.5, and then here I can just have my negative 1, right? Remember the graph of cos, right? Remember the graph of cos. You don't have to cram it, but it starts here. We covered the graph of cos. It starts from there, 0, 1. But in this case, it will start from here, right? So remember what we were told. We were told that it's now going to take 180 to complete one cycle, right? So it means that our graph will go from here, right? So let's draw it. So our graph will go from here, right? We do need our x coordinates, but I can simply tell you that the graph will go like this, that doesn't look nice at all. That's gonna be the first graph. So I'm not sure why I'm unable to. Okay, I think this should suffice. I'm trying to find a perfect shape, right? So this is my first graph, right? And then if it continues, it will continue from here right? It will continue from here to here. However, it's very important that you know that this is the first one, right? This is the first one. So now instead of it taking 360, it took 180 to complete what? One circle, right? Ordinarily, this is the original one, right? If we draw the original one, it would have started from here, right? It would have started from here. It would have, it would have started from here. It would have started from here, passing through somewhere and turning on here. Right, so ordinarily this is how this one would have looked like. Right, so let's just try to draw it neatly. Should be until, yeah, I'm not drawing this to scale. I'm not drawing this to scale for now. Yeah. Right, so this would be your y is equals to your sine of x, and then now this one, right, this one would be your y is equals to 1 over 2 cos of 2x. So as you can see, what we have done here, we've actually halved the period. We've halved the amplitude, and halving the amplitude, we also have halved the period, right? So this is how the changes affect the graphs, right? This is how the changes affect the graphs, right? Usually it's not really important to know the turning points, right? I mean, the x-intercept and the y-intercepts, right? But you can always find them. You know that for y-int, for example, if you want your x-intercept, it means your y is equals to 0, right? So you have 0 is equals to your cos. So you will just say 0 is equals to your cos, your 1 over 2 cos 2x, right? So, however, this is just gonna cancel. So it means that either way you are gonna be left with, you will have to do calculations there. So it's gonna pass through 90 degrees, right? So this will be your 90, because your cos of inverse is 90. So this is gonna be your 90 degrees. This is gonna be your 90 degrees. It's 180. Then this, in fact, it should be 270. Yeah, this should be 180, and then this should be 270. Yeah. So it means that even our graph was supposed to, this one was supposed to turn here. So what we can do is we can just extend this one properly. We can just do this and make it here, and then this is gonna be your 270. This should be your 270, right, where it's gonna turn, and then now sorry about that. Great, and then this would have been your y is equals to sine x. Great, so now let's look at other questions. Right, so if we now look at another question, right, which is question number 3. So here we have a very different yet interesting question, right? It's quite different, but yet interesting. Right, so you have now y is equals to negative. So what does this negative mean? So you have y is equals to negative sine 3x, right? So this negative sign here, so let's just, this is quite important. So this negative sign here, right? So let's just take this again, paste, right, and we are looking into writing this. So this negative sign, right, so this negative sign, what it means, right, it means that the graph will be a reflection, right? It will be a reflection. It will be a reflection about the x-axis, right? It means that if the graph starts by going into the positive y-axis, right? If the graph starts about going into the positive y-axis, if there's a negative, then now it means that it will be a reflection about the x-axis, right? Great, so it's a reflection of the positive one about the x-axis. But let's go ahead and try to answer this question, right? So this is quite important. It is quite important. We don't have to make mistakes, right? It means that the values will just, and it's always good to make tables, right? It's always very good. It's common practice. You must always make tables when you do these things, right? So now let's go ahead and try to find, the first thing that we will want to find is the amplitude, right? Is the amplitude. So the amplitude is going to be the absolute value. Remember, we always want to write this in the form of a sine bx, right? So the absolute value is going to be -1, and then this is going to be 1, right? It's +1, right? Take note, it's +1, and then the period is going to be, remember, it's p is equals to 360 degrees divided by 3, right? So if you say 360 degrees divided by 3, that becomes 120, right? It becomes 120 degrees. Right, becomes 120 degrees. So it means that now it's going to take it's going to take us what? It's going to take us 120 degrees to complete one cycle. Right, so now we have what we need. What we can do now is try to draw the graph, right? So as I said, this will be a reflection about the x-axis. You can try draw tables. So what you can try to do is you can just draw tables, right? You can just draw tables. So what I mean is your table of, you will have your x, you will have your y, and then you will have your 0 degrees. You have your 0 degrees, 90 degrees, 120, 120, 180, so on and so on and so forth, right? You can try to do it by drawing the tables, right? It's a tip, right? But this is how we can draw this graph, right? So this is how we will draw the graph. It means now it's going to take us 120 degrees to complete one cycle. And remember, it's a what? It's a sine graph, right? It's a sine graph. It means that it will start from here. So it will start from the origin, right? But before we go into drawing this, right? So before we go into drawing this, so let's just say this is an example, right? I want you to notice this. This is an example. So you will have your graph here. So let's just do it properly. Oh, great. So this is your y is equals to your positive sine x graph, right? So y is equals to positive sine x graph. So take, for instance, if you have now your y is equals to negative sine x. So it will be that what we mean by reflection about the x-axis. This is how your graph will look like, right? So now this will be your y is equals to negative sine x, right? So you will still have your negative sine x. So this will be your graph here. This is what we are talking about. And so this is what we are talking about here. And then here you still have your graph, which is this one. Right, but as you can see, they are not the same, right? And then here you will have your 1, here you will have your negative 1. This is your 0, this is your going to be your 360 degrees, and then this will be your 180 degrees, right? So this is what we mean, right? So this is what we mean. This one is negative, right? And then as you can see, this one is positive, right? So now let's go ahead now and draw the graph that we have. Let's go ahead now and draw the graph that we have. So the graph that we have, it's gonna be like this, right? So the graph is gonna look something like this. So this will be let's just say, so if we have 120, right? If we have 120 divide here, so we'll just say it's gonna be 60, then now it's gonna be 120. Yeah, it's gonna be 120 or 60, 120. And then now 120, and then here it should be 240, and then here it will be 360, right? So yeah, I think that's the correct one, but you can always use if we use a scale of 128, you can always use what we call 214 and 360. So let's just do it properly. Yep. And then this is gonna be 360. So it's gonna be a long graph. So let me see if we can't use, yeah, no, 60 is fine. We can use, yeah, so you can always decide on the scale, right? You can always decide on the scale. Let me see if I can have the correct scale, the right scale. 120 divided by let's just say divide by, yeah, I think I prefer this one. 60, 120, 180, 240, it's gonna be 300, right? And then you will have 360. So we can just add here and do this. We can just say 60, it's gonna be 60, 120, right, 180, 240, 300, and 360. Right, so now we know that it takes 120 to complete one cycle, right? So, and we know that you have your 1, you also have your -1. So now the graph will start, let's just throw it a bit up, -1. So now if it takes us 120 to complete one cycle, means we will have something looking like this. Nope. Right. Okay, I don't know why it's not doing the nice curve. That's fine. And then you do continue, right? So on and so forth. Great. And then the original one would look like something. This will be your original graph. This will be your original graph of sine x. Right? Great. So this now is your y is equals to your sine x, and then this will be your y is equals to a negative sine 3x. Right. So now let's look at the last graph, which is a graph of tan x, right? So let's look at the last graph, which is a graph of tan x. It's not usually complicated. Remember, the graph of tan x does not have an asymptote. does not have an amplitude. It only has a period, and the period is 180. So we just need to find the period. So the period is going to be 180 divided by b. And what is b? B is 3, so it's going to be 180 divided by 3. And 180 degrees divided by 3 is what? It's gonna be 60 degrees, right? Great. So when we draw our graph, it's gonna be very simple. So you will have, this means that you will have, means that your asymptotes, right? Your asymptotes will be, the simplest way, means that your asymptotes will be at x is 60 degrees, so on and so forth. That's what it means, right? So you will have your x, your y, and then you will have your x, right? This is your x, this is your y, and then you will have your asymptotes at x is equals to 60 degrees. X is equals to 60 degrees. Even here, it's going to be x is equals to 60 degrees. Even here, it's going to be 120. Even here, it's going to be 120. Right? So your graph will be something looking like this. Right? Your graph will be looking like that. And then even here, it will look like something like this. Nope, it's not supposed to be a straight line. Great. And then, nope. Oh, come on. Oh, no. Great. So this will be your 60 degrees, negative 60 degrees. In fact, this is what we should do. Negative 60 passes through here. And then the same is true here. That's gonna be your 60 degrees, right? And then this will be your 120. And then this will be your negative 120 as well. So this will be your graph, right? The graph of y is equals to your 3 or 2 tan 3x. Right. Thank you, grade 11s, for joining in. I hope that was understandable. We will see each other on another video where we will do more complex questions. Thank you.